Good afternoon. It is Sunday, May 23rd. Following up after yesterday's diversion relay failure, I'm back home. That's basically the exact same thing that is up north. This is the G4 controller for 24 volt. Very same relay though. Mine has never had any issues, but I am going to be putting in the solid state relay, the same one that I used there that fried instantly when the control box tried to activate it. So I'm just going to test the duty cycle on it. My dump load runs to a 600 watt water heating element, so it'll be a similar load as the one being used at the other system. That's a 600 watt resistive load. You know, it's a 600 watts is 600 watts. So I'm going to get this swapped over, and there's not a ton of power coming in today. It's cloudy and windy, so you know, turbine's moving, but not crazy power at all coming in from solar, but I'm not too worried about discharging. So yeah, I'm going to get this swapped out, and then I will lower the set voltage on that controller so it activates the relay, and we'll see how it performs under 24 volts with a 600 watt load, and if it holds up. I think what we're going to try and do up there is again use the same relay, the solid state, but then just have a step down from the output wires on the control box, because you know his has got 48 volts coming out, and that fried the SSR instantly. It's got a max of 32 volts on the control side, so that was disappointing. I was really excited that was going to work good, but anyways, let's get this swapped out and we'll see what happens. Alrighty, well, there's the SSR. Voltage is currently at 25. And those of you that have purchased these and didn't read the paperwork, they're really easy to program. You hit the set button. Now this 28.9 is the voltage at which it kicks on. So I can hit the set button again. The blinking number is the one which you can change the value, and the enter button is how you change the value. So, oh, went too far. 25. I'll just set it to activate right at 25, so it'll activate just as soon as I get out of the program mode, and then we'll set it to deactivate at 24.2, and then you gotta go hit set 1, 2, 3, 4 more times. Ah, darn it. I must have double tapped it. Buttons are sensitive. There. So, see the light on? That's what the one up north did for about 5 seconds, and then she fried. Is it warming up? Well, it's not warming up super fast anyways, if it is. But it's running. And what that is running to, I follow this wire. This is the hoses that go to and from my solar thermal collector outside. Follow this wire down, 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 down. And that is a 600 watt water heating element that I bought from Thermodyne. Yeah, and that's warming up. So it's working. Okay, cool. It's actually cold as hell outside. The weather turned on us, so I've got the system switched over to the chimney pipe, and I've got a small fire going, so our fire is also heating the water because I'd like to take a bath tonight, but I didn't want to overheat the house, so I disconnected the pipe that goes up to our HVAC system. That's what blows the heat into the house from the wood furnace. I disconnected that, so it's only heating up the basement, and that is just helping the chickens stay warm. I see the light is still on, so it's not dipping the voltage too fast, which is good. There is still some power coming in from wind, a little bit from solar. So it is going to sag my voltage, you know, it's going to bring her down. But we'll let this run for a while, and so the heatsink is warming up. Let's grab the infrared. The relay itself, the plastic housing, is not even like warm to the touch. It's just room temperature. And again, these things give really inaccurate reads, especially on anything reflective. You almost need to like find a corner. Oh, I saw 118. So yeah, that's getting hot. See how I mounted this sideways, so, you know, heat rises. These heat sinks are designed in a way that the heat can just draw away from them. As they warm up, the air will draft upward, and it'll draw in cool air, and it'll expel the warm air upwards. If I were to turn it, it would work very inefficiently. The fins on the top would, you know, not really they would be cooler than the ones on the bottom, which would be storing heat up if I had it mounted like that. So the heatsink is definitely working. I went heavy on the paste there. There's a paste that you stick in between them. There's a metal plate behind this, and you stick that right to the heatsink, and if you put that thermal paste in there, it really transfers the heat to the aluminum and just draws it right off. It's finally warming up just a little bit on the housing itself. So, alright, we'll keep an eye on that. If anything drastic changes, I'll get it on tape. Otherwise, I'm going to let this run basically until it deactivates. So when battery voltage gets below 24.2, it'll turn off, and then I'll come back and we'll time it and see what happens. Alright. Alrighty then. Finally kicked off. Took about 15 minutes for the voltage to sag down to 24.2. 600 watt load on 1000 amp hour battery bank, going down 0.8 of a volt in 15 minutes with, very minimal power coming in. That's pretty awesome. The big thing, the main purpose for these diversion loads is to prevent spikes. Let's say if I had 1200 watts of solar coming in, the sun came out, the clouds parted and the sun came out, and the wind picked up, and all of a sudden, that's making 600 watts and that's making 1200 watts. It would spike voltage real fast. These catch the spikes. That's the idea. So it doesn't overvolt the batteries. That's bad for the batteries. It can make them foam, and the inverters don't like to be overvolted either. They'll shut down if they exceed input voltage. But SSR handled it. It got up to, I tested, I kept an eye on it the whole time. It's cooling down already, so it's probably still, I don't know, 100 degrees. Well, 120. Got up to about 135, I saw. Looks like voltage might climb back quick enough to reactivate it. That might be another good test for it. So we'll set the deactivate voltage higher and see how it fares, clicking on and off, on and off, on and off. Well, maybe I'll just set the whole thing lower. It's really easy to double tap these buttons. Okay, so we're set for 0.2 of volt difference. It'll activate at 24/7, deactivate at 24/5. Let's see how fast it will. Now you see it's at 24/7, but it has to get above that to activate. Boom, there it goes. and it has to get 1/10 below the set point to deactivate. So you saw the light. Yeah, there she goes. And there she goes. So the controller is functioning properly, and the relay is kicking on and off as prescribed. Okay. Let's set it for 1/10, so it goes back and forth. Okay. You know, I want to know if it's okay for this thing to click on and off. Obviously it's going with wind gusts. That's what's pushing me up over. On, off, on, off, on, off, on. Oops, sorry. Cool. Well, I'm going to let it do this for a while, but I'm going to go ahead and call this test a success, because this is what I expect it to do. You know, obviously I'm going to have my activation, deactivation set differently for a normal day. This is just strictly for testing purposes. I'm trying to abuse this relay and make sure it's going to hold up to it with my dump load, and then also with the dump load up north. The resistor bank is 600 watts on that thing, which is very same as I'm using here. So I think if we use the voltage step down, 48 to 12 volt step down, and then use that just to activate the relay. Oh, I didn't tighten that. That'll work fine. And then the 12 volts, they'll be, because these controllers, you know, the control side of the relay uses virtually nothing. You know, it's just voltage goes through, and it's bimetallics internally. The silicon switch allows power to transfer through these terminals. There will be plenty of leftover juice coming from this line out of the voltage step down to run a small computer fan. I'll get just a little bitty guy, and you know, maybe zip tie that to the heatsink from the underside, so it blows air up from underneath it, and that will really make a big difference. You know, I doubt it would ever get over 100 degrees with a fan blowing that air away. So that's that. Very cool. I'm happy. I probably should have done this test before trying this up north, but you know, that's that's off grid. Win some, you lose some, and parts fail, and you have to test them. And when you first hook something up, you have to sit there and hang out, make yourself a cocktail or whatever, get comfortable and watch it, see how it behaves, monitor temperature, feel your wires, feel your different connections, make sure everything's tight, because all that stuff plays a role in safety and longevity. So I'm gonna pretty much watch this for the next hour, and if this relay doesn't smoke being abused like this, kicking on and off and on and off and on and off with a 600 watt load, I'm gonna call it good, because it's not going to be kicking on and off so fast when I have it set for a normal day. A normal day, I would have activations set for 29.2, deactivations set for 28.9. So it's only dipping her down 3/10 or 4/10, 3/10, but it's enough to catch a spike that's going to foam my batteries or overvolt the inverter. But that intermittent current to the water heater is going to help the solar thermo. It's not a lot, but it's help. So and in the system up north, that pulsating power is really good for rehabbing batteries. That's how I brought this bank back. I had this set to my diversion load for about 6 months. I had gotten 3 years of use out of these batteries, and I added these guys last summer, and kicked these down here, wired them to the diversion load, and any excess power went to these, and it just, slow pulsating power every single day. There was nothing drawing off of them, just adding power. Slow pulsating power brought them back, and I can test the chemistry in any of the cells, and they're good to go. So I tied them back to my bus bars, and they are part of the primary bank now. And now voltage rises and lowers a lot slower. It doubled my amp hour total capacity by tying these back in, and that's what I wanted to do. I was really sad about these kind of going south so fast. They were cheap, but I did manage to bring them back and didn't have to use any magic tricks like Epsom salts or anything like that. Just a diversion load, and it was a useful diversion load for about 6 months until they filled up. They were full. They were sitting here super full, and they weren't drawing against the system anymore. So when that activated, they weren't pulling anything because they were full. So anyhow, thanks for watching. God bless you. Take care.